So in this example, we get to practice our exam technique again, or in fact the way we will approach any question, whether it be an exam from the textbook, wherever. In that, we'll read through once, come back and read through for a second time and underline the key points, then identify those as the beginning of our solution. So if 12,500 is invested at 4.8% per annum, with the interest compounded monthly, calculate the final value and total interest earned over 2 years. Okay, so there are a few different things there that let's have a second read through. If 12,500 is invested, well, obviously 12,500 is invested. This would be our P. At 4%, it's got its percentage on it, per annum, per year, with the interest compounded. Now that is really, really important. And monthly, we've got lots of conflicting things here. Monthly, per annums, that's going to be an issue. Compounded, critical piece of information. Calculate is the final value, and total interest earned over 2 years. Look, there's almost nothing that can be ignored in those two lines. It's really important that you now begin your solution by identifying the parts of this question that I've underlined. If 12,500, that's obviously our P. That's the amount that's been invested. The rate is 4.8% per annum. We know immediately that has to be a decimal. It's compounded monthly. That means my units are months. Monthly must be the unit for R and N. What does that mean? Well, that has an impact on the rate. Now, if this is the rate for the whole year, you probably know a month is 1/12. So we need that rate to be divided by 12, and then it will be per month. So we go to the calculator, get up our fraction button, turn it on, get up our fraction button, and we're doing 0.048, dividing it by 12 equals 0.004, and that is per month. Fantastic. Calculate the final value. Find the final value. This is suggesting that we use the final value, the way the formula is written with final value as the subject, and find the final value and the interest. So we've got two things. 1, 2. Highlight them, underline them, do something so that you don't only half answer the question. Over 2 years. N is 2 years, but hang on. We said back here, monthly must be the unit for R and N. So I can't leave my N in terms of years. We've got a problem there. But I know that 2 years is actually 24 months because there's 12 months in 1 year. So now my values become, no problem with P, R has to be this value and N has to be this value. So I'm going to, and I'm finding the future value is the present value times 1 plus R to the N. So the future value is our 12,500 times 1 plus R, 1 plus 0.004, and N is 24. So it's 12,500 times. Now, you can go to your calculator and do this, or you can realise that if I add 1 to this decimal, it just means the number in front of the decimal point becomes a 1. 004 to the 24. Go to your calculator and I will just try to move that so that you can see what's going on. And so I've got 12500 times bracket 1.004, close the bracket, x to the y is the key you use there, to the 24 equals 13,756.85. And so we've got 13,756.85. Now, the question asks for not only the future value, so that would be our future value, but also the interest. Remember me writing before that the actual compound interest earned is the difference between the future value, which is 13,756.85, which is the amount that's in the account at the end of the investment period, minus the amount that was put in, which is the 12,500. So again, going to the calculator, clear that, and again I'll move this over, and this time we want 13,756.85 subtract 12500, which equals 1256.85. So that's answered those 2 parts to that question. I'll stop the video now and do the next example in another video.